Hi everyone, and thanks for joining us today. I am excited to talk about a powerful shift in machine learning operations and one that's making a real impact across the industry, serverless architecture. Over the next few minutes, I will show you how this modern approach to infrastructure is not just a buzzword, it's delivering serious results. Organizations are slashing operational cost while doubling the speed at which they will deploy the machine learning models. We'll walk you through the core principles of serverless AI, share findings from our cost industry research, and give you the practical framework that has been like a proven in real world implementation. So you can take these ideas and apply them right away in your organizations. Before we dive in, let's have a quick intro. I am Tarun Kumar Chatterjee, and I have spent past few years working at intersections of AI, cloud architecture, enterprise transformations, machine learning, etc. You can find my contact details and LinkedIn here on the slide. So I am always open to connecting and answering the questions and continuing the conversations after the sessions. So feel free to reach out to me. Let's look at the real impact serverless machine learning is having. Organizations adopting serverless architecture are seeing a huge improvement starting with a 65% reduction in infrastructure management overhead. That means less time spent on maintenance and more time focused on innovations. On average, they are also seeing like a 40% in cost savings compared to traditional deployment methods. But perhaps most exciting models deployments has jumped 3.4 times annually, and teams are able to iterate and ship models faster than ever before. And it is not just a back-end improvements. Users' engagement is up to 28% is in products that have implemented serverless AI, showing a direct link between the architecture and end-user impact. What this tells us is simple. Serverless doesn't just make the things more efficient. It unlocks scales, speed, strategic focus for data teams. This slide really highlights one of the most dramatic benefits of going serverless deployment speed. Traditionally, deploying a machine learning models would take around 2 to 3 weeks, with teams stuck in a cycles of provisioning infrastructure and configuring the environments and setting up the manual scaling. With a serverless transitions, those steps has shrinks to about 3 to 5 days, and team focus on the things like the configuring the API gateway, containerizing functions, and integrating with the cloud provider. But the real magic happens once you are really less and deployments drop to just 2 to 4 hours on an average. So everything is automated. There's no infrastructure to manage, and scaling happens instantly. So this kind of speed is not just nice to have; it's a really competitive edge. And in industry where rapid iterations and AI-driven features define the market leaders, so the ability to ship models in hours instead of weeks is a game changer. These slides focus on the financial side. This bar chart breaks down exactly where serverless machine learning earns its reputations for cost savings. On average, organizations are seeing like a 40% reductions in cost compared to traditional machine learning deployments. And it's not just a one area. The savings came from four key fronts like infrastructure, maintenance, scalings, and DevOps. With serverless, you do not need to over provisioning hardware. Maintenance is minimum and scaling is automatic, and DevOps efforts drop like dramatically and by using the tool. What really stand out here is the pay per use model. So it's a perfect fit for the machine learning where the workloads often spikes around training or deployment but remain ideal in between. Serverless ensures that you are only paying for what you use, which means no wasted spend during the downtime and full powers when you need it. Great. And these slides really showcases like one of the core strengths of serverless for machine learning. One of the most powerful features of the serverless machine learning is the elastic scaling, and the pyramids is break it down. And the top, you have the peak performance. Serverless systems can automatically handle thousands of concurrent predictions requests without skipping a beat. And beneath of that, like a dynamic scalings and the ability to instantly adjust to real-time traffic changes. So there is no manual tunings or the planning needed. Then we have the predictive capacity. Some systems even leverage machine learning themselves to anticipate usage pattern and allocate resources ahead of demand. And finally, it's all sits on a cloud foundations distributed across the multiple availability zones for resilience and the performance. What that means, like in practice, is simple, and organizations no longer have to over provision infrastructure just in case of a traffic spike. And during real world, like 10 time traffic surge, serverless machine learning systems maintained stable and low latency responses and delivering consistent AI performance when it matters most. These slides connect the technical improvements to real business outcomes. Now let's talk about the operational efficiencies, because serverless is not just about the savings times or money, it's also about doing more with the same team. Organizations are moved to the serverless were able to deploy 3.4 times more models annually. And that's a massive leap in output. And it changed how fast team can respond to new opportunity and challenges. So looking at the pie chart here, deployment velocity improved by 72%, giving team the ability to ship updates and improvements faster. Model diversity increased to built-in support for multiple frameworks like TensorFlow, PyTorch, and others. And the continuous deployments become the norm with the automated CI/CD pipelines, reducing the frictions from experimentation and to the productions. And then finally, more rapid iterations unlocked the new innovation potentials, leading to smarter and more adaptive AI features. And its payoff, organizations saw like a 28% boost in user engagement after implementing these serverless powered AI features. And that's a direct line from architecture to business impact. And this is a great slide actually for grounding the strategy in a real world architecture. So here we are looking at a layered architectural pattern that emerged as a best practice for serverless machine learning deployments. Starting with the data ingestions layer, everything is the event driven from the streaming data to automatic features extraction and optimized storage. This ensures raw data is immediately usable for the machine learning. Next, the model training layers usually uses like a formal compute, meaning compute resource spin up like only when it need, and we can get on-demand GPU access and hyperparameter tuning functions and the ability to scale out the distributed training jobs without managing the infrastructure. Then we move to the inference layer. So where we train models are containerized and served behind an API gateway. We can have automatic scaling in points and model problem versioning, testing, caching for high frequency queries, all fully managed. Finally, the monitoring layer and the ties it all together with performance matrices and model drifting detections and even automated retraining triggers. So your models stay accurate and relevant over the time. This structure allows teams to scale and optimize each part of the machine learning life cycles independently while still benefiting from the flexibility and the simplicity of serverless computing. This slide ties everything together by showing the real world impacts across the sector. Let's wrap up the core content by looking at how these serverless machine learning strategies are being applied across the different industries, each with their own unique challenges and goals. So in financial services, like serverless machine learning is powering like a fraud detection systems that reduce false positive by 34% even as transactions volumes increased 5 times. These models runs in real time and continuously adapting to new fraud pattern, no downtime and no batch delays. So in healthcare, serverless functions are being used for medical imaging analysis. What used to take days can now be done in a minute. So these systems scales automatically to meet the patient's volume and the remain HIPAA compliant, which is like Health Insurance Portability and Accountability Act compliant, even with the massive data sets and distributed processing. And in a retail, companies are using like a serverless machine learning to deliver hyper personalized recommendations, and these have been like a 23% boost in average order values thanks to the model that updates continuously in real time. This also supports seasonal forecasting and the inventory optimization. So the key takeaway here is while the underlying serverless principles are the same, implementing the strategies must align with the industry specific needs, whether it is compliant and the speed and the customer experience. These slides focus on how to refine the performance. So performance optimization is a key of getting like the most out of serverless machine learning, especially as the workload scales. So let's dive into some techniques that have been proven to make the big difference. And first, the model compression. So by using this technique like quantizations learning, and knowledge distributions. So you can reduce like the model size up to 60 to 80%. This helps you to fit your models within the serverless deployment constant without sacrificing the performance. Then we have the cold start mitigation. So serverless environments often face like latency uses when functions have to warm up, and to solve this, you can implement the warm cooling strategies and preload common models and manage functions concurrency to minimize these impacts. Memory optimizations is another big win. Right sizing memory allocations based on the model needs to ensure that you are not over provisioning or underutilizing resources. So pair that with the adaptive batching to maximize throughputs, and you have got a lean and efficient setup. Finally, caching strategy by using like a multi-level caching at the API gateway functions and the database layer, you reduce redundant computations and speeding up the inference times and the lowering loads. So now what the result? Like companies using these strategies reported a 65% improvement in response time and an additional 25% cost reductions beyond the initial serverless savings. The best results comes when you combine several of these techniques and tailored to the specific models and usage pattern in your environment. These slides provide a step-by-step roadmap. So our delivery should be clear and structured, and successful serverless machine learning adoption doesn't mean starting from the scratch. So the key smooth migrations is integrating serverless capabilities with your existing machine learning workflows, and it can be done in three main phases. The first is the assessment phase. This is where you evaluate your current machine learning workloads to identify the candidates for serverless migrations and focus on models with variable inference pattern or those that requires the frequent updates. So you will want to perform like cost benefit analysis to determine the best workloads for migrations, taking into the account usage pattern and scaling needs and any technical constraint. Once you have assessed, and it's the time to start the pilot implementation. So begin by migrating the non-critical models to minimize the risk. During this phase, you will refactor the model for the serverless deployments and establish the performance baseline and implement the CI/CD pipelines for the automated deployment. Key tasks here need to include like the containerizing your models and configuring like cloud services and setting up the monitoring to track the performance. The scale and optimize phase comes after the pilot. Once you have seen the success with the initial model, expand to additional workloads. So this phase is all about like fine tuning, optimizing the performance, and creating the internal best practices. As you move like higher value models into the production, so document everything to share across the team and ensure the smooth transitions. And our research shows like that following this phased approach reduce like migrations risk and accelerates time to value. In fact, 87% of pilot project made into the full production within just 3 months. To wrap it up, let's go over the key takeaway and the next steps. So first, when we starting like our serverless machine learning journey, focus on the interference workload with a variable traffic pattern. These are often like the best candidates to see immediate benefits such as improved cost efficiency and the scalability. Next, make your the implementation focus specific to your models, prioritizing like the optimization techniques that align with the characteristics of your workloads, whether it's model compressions, cold start mitigations, or the caching. Lastly, for the long-term success, develop a comprehensive serverless machine learning roadmap. This will guide your migrations and ensure the serverless principles are woven into your long-term AI strategy. In summary, serverless architecture is revolutionizing like how organizations deploy and scales AI. It can reduce the cost by 40%, and organizations are deploying 3.4 times more models annually. The elastic scaling handles the unpredictable traffic and empowers data science teams to focus on what they do best on the innovations. So to get started, identify a few high impact inference workload from a small cross-functional team and develop proof of concept using the architectural pattern we have discussed today, and measure your result against the established baseline and use those insights to build your comprehensive serverless machine learning roadmap. Thank you all for your time and attention today. And I hope you found the insights on serverless machine learning valuable, and that you are excited to explore how this approach can transform your organizations. If you have any questions or you would like to discuss further, feel free to reach out to me after the presentation. I am happy to connect. And my LinkedIn details are already in the very beginning of the slides. So you can. And thanks again. I look forward to hearing you about your serverless journeys. And thank you.